In this video, I'm going to be looking at quite specifically a bit of organic chemistry that pops up on a lot of exams, and this is oxidation reactions of alcohols. So these are very basic reactions in terms of AS organic chemistry, but they crop up all the time. They almost underpin many topics in the course, and they will come up again in the second year of A level when you look at things like esters and carbonyls and testing for carbonyls, and there's lots of extra stuff that gets thrown in. So it's really useful to understand clearly the basics. And just because there are more complicated things you can do with these, it does not mean for a minute that you're going to get, a dead hard question. It might actually be something that just talks about oxidation. So I'm going to run through this one question here now. It's a 6 marker, and it's asking about oxidation reactions of propan-1-ol. So a lot of stuff to unpack here. It's 6 marks, but hopefully you'll see as we go through it what they're asking for. In my opinion, doesn't really get to 6 marks. It's not really, what you actually have to put down. You might not think it was a 6 mark question, but they'll give you 6 marks for it. So really useful again to understand fully how these work. So describe the oxidation reactions of propan-1-ol, suitable oxidizing agent. So that's important. That's the first bit. We need to talk about what the oxidizing agent is. Indicate how reaction conditions control which product. Include reagents and observations and equations in your answer. And we can use structural formulae. So again, be careful here. It says structural formulae, so not skeletal. And we need to use O to represent the oxidizing agent. So lots of stuff here to be getting on with. So first things first, I'm going to write down the oxidizing agent. Okay, so hopefully by now, hopefully this is an easy bit, but people forget this. People will forget to do this. They'll forget to write, acidified potassium dichromate. Okay, or just dichromate, Cr2O7 minus. You can write down acidified potassium dichromate if you wish, but I don't want to because I can't be bothered. I prefer writing as little as possible. So that's 1 mark, by the way. That gets you the first mark, just by writing that the oxidizing agent is the dichromate ion, and this acidified. Now, there's 2 different ones here, and we need to use structural formulae. So we need to be careful here. You need to be just aware of what structural formulae actually is. So students will occasionally miss that part of the question. They prefer to use skeletal or displayed, and then they lose marks. So propan-1-ol then, so we're going to have to use, so the first equation, we're going to do the first one. So we're going to start with propan-1-ol, CH3, okay, CH2, CH2OH, that's propan-1-ol, and we're going to oxidize it. So there's 2 possible reactions here. Okay, so the first one, we're going to add O, okay, and we're going to make an aldehyde. So we're going to make an aldehyde here, and again it says include reaction conditions. So remember, to make an aldehyde we need to distill. Okay, it's important we put that down. So put it over the arrow, that's fine. Distill it and we make an aldehyde. Now the aldehyde is CH3, CH2, CHO. Okay, so we've taken off 2 hydrogens, we formed a double bond to the oxygen, single bond to the hydrogen, and we make water. Yeah, nice and straightforward. Okay, so everything balances, nothing complicated here, everyone's happy. Okay, nice and easy. That's the first equation. Again, that will get you a mark, and the observation, of course, will, well, not the observation, but the reaction condition will get you a mark. We'll go on to observations now. Okay, now the observation is what you will see. Now, if you recall, this is a very important point. The dichromate ion, okay, has a color. And the observation, that's also for obs, is when these reactions take place, the dichromate ion is orange. And as the reaction proceeds, the dichromate ion gets reduced to Cr3+. and that is green. So it's orange to green color change. That's very important to note down. Okay, so we've got our observation, orange to green color change. Dichromate ion is used. That's 2 marks already. We've got 3 marks, 4 marks here from the distillation. The final couple of marks now is just doing the second reaction. Now, obviously, if we do propan 1-ol again, there's a second reaction we can do. And we're going to add O again, and we're going to reflux this time. We're going to go full oxidation, and we're going to form a carboxylic acid. Okay, so these are reactions, unfortunately, you have to just remember, okay, these pathways, okay, if you don't know what these reactions are, you need to go and look them up, okay, because if you don't know what oxidation of alcohols gives you, then it's something you need to learn before you start trying to write equations on it. So there you go. You've got an oxidation reaction to give you a carboxylic acid instead of an aldehyde. And the difference in the reaction conditions gives you the different products. Only thing we're missing here is we need a second oxidizing agent here. So second, so we've oxidized once to distill it to get to the aldehyde. The second time when you reflux it, you add another oxygen. So that's why you need a second O. Notice, however, that you don't have a second water. Okay, there are no hydrogens given off. Okay, there's no hydrogens given off. So just be aware of that. Okay, it's very, very important. So we don't have a second set of water being given off. And in terms of the question then, so that's essentially it then. In terms of this question, this is all you have to write and you get 6 marks. Okay, it is very, very straightforward. However, it does require a lot of underpinning knowledge, and this is what the important part about this course really is in terms of chemistry. It's having that underpinning knowledge. If you know that you've got oxidation to aldehyde and carboxylic acid, and you can confidently write these equations, these are 6 marks you can pick up in seconds. Okay, just make sure, of course, when you have a lot of words in the question, you just tick off everything. So, for example, it's very easy here, but I've highlighted everything. I see people highlighting things all the time. A better thing to do would be to highlight and then tick it off when you've done it. People highlight all sorts of rubbish in exam questions. They take their highlighters and they highlight every other word. You only do it if you've got a reason for doing it. So I've highlighted the things I need to include. Did I pick a suitable oxidizing agent? Yes. Did I put the reaction conditions? Yes. Reagents, observations? Yes. Yes. Equations? Yes. Structural formulae? Yes. Did I use O? Yes. That's it. Use it as a checklist rather than I must highlight everything to remember it. Use it as an actual purposeful thing rather than just I want to highlight everything to remind me, because eventually all you'll be doing is looking at almost entirely highlighted text and nothing else. So there you go then. I'm just going to do that one question because again the majority of these questions all are variations on a theme, and this is probably the hardest type of question you can get on this sort of topic, but once you understand the oxidation processes of alcohols, it is all hopefully relatively straightforward.